Welcome to our lesson on the properties of bases. In chemistry, bases are a fundamental class of compounds with unique characteristics. Today, we'll explore what makes bases bitter, slippery, and chemically reactive. Understanding these properties will help you identify bases and predict how they behave in different situations. Let's start with the definition. Bases are substances that have a pH greater than 7. When dissolved in water, bases release hydroxide ions, represented by the chemical formula OH with a negative charge. This release of hydroxide ions is what gives bases their characteristic properties. The higher the pH above 7, the stronger the base becomes. Bases have two distinctive physical properties that make them easy to recognize. First, they taste bitter. Think of the bitter taste of baking soda or soap if you've accidentally gotten it in your mouth. Second, bases feel slippery or soapy when touched. This slippery sensation occurs because bases react with the oils in your skin, creating a soap-like substance. However, remember to never deliberately taste or touch unknown chemicals. This is extremely important for your safety. Never taste or touch bases to identify them. Many bases are caustic and highly corrosive. They can cause severe chemical burns and permanent tissue damage to your skin, eyes, and mouth. Strong bases like sodium hydroxide can cause injury within seconds of contact. Always use proper safety equipment and follow laboratory protocols when working with bases. Now let's examine the chemical properties of bases. First, bases turn red litmus paper blue. This color change is a simple and reliable test for identifying bases. Second, bases conduct electricity when dissolved in water because they produce ions in solution. Third, bases react with acids in a special type of reaction called neutralization, producing salt and water. This neutralization reaction is fundamental to many chemical processes. The neutralization reaction follows a predictable pattern. When a base reacts with an acid, they produce salt and water. Here's an example. Sodium hydroxide, which is a base, reacts with hydrochloric acid to produce sodium chloride, which is common table salt plus water. This type of reaction is called neutralization because the acidic and basic properties cancel each other out, resulting in a neutral product. Let's look at some common bases you might encounter. Sodium hydroxide, with the formula NaOH, is used in drain cleaners and soap making. Ammonia, NH3, is found in many household cleaning products. Calcium hydroxide, CaOH2, is used in cement and whitewash. Magnesium hydroxide, MgOH2, is the active ingredient in antacid medications that neutralize stomach acid. Each of these bases has practical applications in everyday life. Let's review the key points. First, bases taste bitter and feel slippery to the touch. Second, bases have a pH greater than 7, indicating their basic nature. Third, bases turn red litmus paper blue, which helps us identify them in the laboratory. Finally, bases react with acids in neutralization reactions to produce salt and water. Understanding these properties allows you to recognize bases and predict their behavior in chemical reactions.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.